OpenStorage on Solaris. Um, and in general, I want to talk about kind of where storage is going, the future of data management, talk a little bit about why Solaris is a good fit for storage applications, and then we'll talk a little bit about the various parts of Solaris and things that are going into Solaris over the next few months that that make Solaris a good candidate for doing these things. How many people have too much space in their data center? Okay, that's pretty typical. The really interesting thing has been that even though disk drives, I've done it again, my phone is betraying me. Even though data centers have gotten much bigger, disk drives are, I guess, up by a factor of about 100 over the last few years. We still have run out of power. We've run out of cooling. We've run out of ability to manage all the things, and yet as the amount of storage that gets created in digital form, it increases over time. We're really not even keeping up, which is the amazing thing. And as a result of that, lots of different things about the way storage is either going to be done or has to be done will be changing. The context of this is that storage in many ways hasn't really changed in maybe the last 40 years. There have certainly been things that have changed about it, but it hasn't changed in fundamental ways. If you look at the way storage is done today, you typically have a disk drive. It's attached through some funny-looking wires, which have funny shapes, right, looking like switches and stuff like that sometimes. And it's attached to a computer, and the computer kind of controls everything. It's a master-slave relationship. The computer is the only one who knows where the data is. It's the only one that knows what data is. If you think about what happens on a disk drive, you can't delete things off a disk drive. The disk drive only knows how to either read or write. And that's because you delete data and you read and write bits. Since we've gotten RAID, I mean, I guess it was about 15 years ago that we really got RAID in a serious sense, and about 5 years after that, we got things like caches and replication and point-in-time copy and things like that. We haven't really changed the way storage has been done, other than to put it on a wire. Well, that's going to change, and the reason it's going to change is that in the next bullet, we continue to have increasing expectations of what the storage will do. We want it to do more stuff for us. For example, we'd like the new laws that are particularly in Europe and America tell IT organizations they have to retain certain classes of data for certain periods of time, or else, well, you go to jail, which is generally considered a bad thing. And we also have to do things like archive data and retain it for different kinds of distribution and repurposing. If, for example, you might create it for publication and then use it for reference later. You may create it in one form and distribute it in a different form. For example, you may convert video formats and things like that. And the way that the systems are organized today is such that only the master, the computer, can do this. The storage can't help you because it doesn't know what anything is. It doesn't know what a TIFF file is. It doesn't even know what a file is. So our increased expectations and the requirements of that are going to force some changes in how storage and the computer are related to each other. Another thing that's changing is that the interconnects, the thing that connects the storage to the computer, have really changed. 20 years ago, the situation was that the storage interconnect was 10 times, maybe 20 times as fast as the networking interconnect. So 20 years ago, you have an SMD disk. It was maybe 3 or 4 megabytes a second. At the same time, you had Ethernet, which was 10 megabits per second. These days, the networking hardware is all the same. You know, they all go kind of about 10 gigabits a second. They're all going to go to the next step at a kind of about the same time. And really looking at